Good morning, everyone. I'm Dylan Che, computer engineer.
And I'm Justin Martin, an electrical engineer.
And today we're going to represent Embry-Riddle Aeronautical University, Arizona campus in IoT and agriculture. IoT, if you don't know, is Internet of Things. In particular, in this case, would be 3G MMS technology, where you'd be sending or receiving images on your phone.
Yeah, so our goal is to use the cellular IoT to help remote monitoring in the agricultural industry, in particular watering holes for livestock. And it will allow ranchers to save time and resources by not having to physically monitor all of their watering sources. And this is also open for other applications such as trail cams, road conditions, and seeing weather.
Okay, so I'm going to explain why. So to give you some background for the agricultural industry, it is a large industry, 2.1 million farms in the US according to the US Department of Agriculture in 2017. And the average size of farm is 444 acres. So imagine if you owned a farm, if you're planning on retiring and you're 58 years old, and you're going to have a huge farm, and you're invested in a $360 billion industry, and if you own any cattle or sheep or anything like that, you'll be in $42 billion in that $360 billion industry. You're going to want to make sure you take care of your resources and your cattle. And in this case, we developed a device that can help you with that with remote monitoring. Using 3G, this device, the Remote Automatic Photograph Testing Device, or the RAT, is it automatically sends an image to the user once a day. It's solar powered, so you don't have to worry about charging it at all. You deploy it, you put it on the field, and you don't have to touch it for a few years. It's compact, weatherproof, can withstand, let's say, a hurricane.
And it is an on-time system that will go through software checks, checking for if there's enough light to take a picture, if it has the proper network connectivity to send the image, as well as testing its own battery power to see if it has enough power to transmit the image.
One single charge can last up to 25 days, so you don't have to worry about a hurricane that lasts 25 days. You're totally fine, and you're covered here. And for the parts cost for 1,000 count units in production, it will cost around $119.50.
And on our device, you can see most of our critical components. We have an antenna out the side, the camera out the front that will take a picture of whatever it's pointing at. The solar panel is on top, as well as a key lock switch on the bottom. So you switch it, that turns it on, and it will keep people from tampering with it while it is out in the field.
So if any of you are planning on retiring on a farm and owning tons of cattle and making tons of money, think about our remote monitoring situation here and our solution to that, and why you should deploy our device in the field in the future.
With that, are there any questions? Yes?
So you have like a network of multiple devices at multiple watering holes or whatever.
You could, yes.
Okay, and you've got, and it's going to shoot a picture. Can you set it for more than once a day? Or?
Yes, it is completely programmable.
Okay, so you program it. How do you know when one's not working?
Well, it will recharge as it will, but if you don't receive an image, that's when you know something might be wrong, so then you might need to go check.
Does the user have to say that, or do you get an alert that said, I didn't get a signal from sensor 20?
So just to interject a little bit, so for this one, we're just a proof of concept here, just to make sure that it can work. So for our more marketable design that we, in the future, they want to develop this in the version 2. Well, definitely we want to be able to text it and a text message, have it read it, and be like, okay, yeah, we sent you an image already today, or we can change your phone number on there, or send me another image today. So it'll be able to communicate. But for this one, it's just turn on, send you an image once a day, and if it's not enough sunlight, it'll probably wait or send you later on in the day, depending on the situation out there.
Question to you, like, this is just solar based only. What happens with, like you mentioned about 25 days and everything, but what about backup? Like, for example, we are putting in the field. Solar cells can damage anytime they heat or whatever. What you gonna do in this? So you wait for 3-4 days. What is the backup plan for that? Any battery?
Yeah, it does have a LiPo battery that will be able to be swapped out if you need to, but it should be able to run on its own for a long time.
Did you arrive at environmental testing of your design?
The container we have is IP64 rated, but with the modifications, we did not finish the environmental testing for waterproofness.
Yes.
Is there a chance that your camera can be just blocked by a natural something that sort of
like a cow?
things like
Yeah, so that was actually brought up, and so image processing could be something to be implemented in the future that, hey, there's too many black pixels going on, we're going to swap it out and send you another picture. But to be honest, the solution to this that we thought about is that if something's blocking it, we would want the user to go out there and check what it is. So whether it's blocking it or not, they're going to send an image regardless, and we decided to do away with the image processing. Maybe at a later version at the user's discretion, but...
Yes, and that's also with getting multiple pictures every day. So you can get a blank image and then later in the day it'll be clear and then you'll know it was just something in the way.